We're doing curve sketching, and I hear you all groan across the room because you remember this from pre-calculus and maybe you didn't love it. But remember, curve sketching is just graphing. It's nothing really scary. We're just looking at certain key features of a function, and then we're going to graph those key features and sketch what the graph must look like because of those key features. So, first things first, we're going to look at these functions and we're going to simplify them. So, these ones we're not going to sketch, we're just going to do a little bit of work that we would have to do to be able to sketch it. So, this one, what is the domain? Well, what would make this one equal to 0 on the bottom? Well, I can go ahead and I'm going to do the reduced function right now. A lot of times on your test you'll see f of x RED, that means reduced. Okay, so the reduced function, we go x plus 2 and then I'm going to factor it. X minus 2, and it doesn't actually factor, or it doesn't actually cancel anything out, right? If I factor the bottom. So what I know about that is that there are no holes. I know that there are vertical asymptotes at 0 and at 2. So what is my domain? My domain is all reals except x cannot equal 0 and x cannot equal 2. We'll just write that not equal 0, comma 2. So that's our domain. So where are our vertical asymptotes? Our vertical asymptotes are at x equals 0 and x equals 2 because we know both of those domain restrictions are not holes, they're not jumps, so they're vertical asymptotes. And then we're going to look at the end behavior. Now remember, end behavior just means horizontal asymptotes. It just means when x gets really big, what happens to this function? Okay, so we look at this and we notice that the top degree is less than the bottom degree, which means the horizontal asymptote is 0. So we're going to write this in limit notation instead of just horizontal asymptote at 0. So we're going to say the limit as x approaches infinity of f of x equals 0. And then we're going to look at the other side. Remember, since this is a rational function, it's going to have the same horizontal asymptote on both sides. So the limit as x approaches negative infinity of f of x is also 0. That's it. Then we could take all of that information and we could actually do a curve sketch if we wanted to. There's a few more things that we will find, and then we'll actually be able to sketch it. Okay, so let's take a look at the next one. The domain of this function, well, what would make me do something illegal? If I put 0 in the denominator, it's illegal, right? So my domain is all real numbers except x cannot equal negative 3 because that would give me a 0 in the denominator. So I have a vertical asymptote at x equals negative 3. Is that an even or an odd vertical asymptote? I forgot to ask on the other ones. These ones were odd vertical asymptotes because they have an odd power, right? This one is, both of them are to the first power. This one has an even power, so this one's going to be an even asymptote, right? So that means that the function is going to go, both of them are going to go up or both of them are going to go down when they're going toward that asymptote. Now let's look at the end behavior. The degree of the top is 3, the degree of the bottom is 2. So is there going to be a horizontal asymptote? No. So the limit as x approaches infinity of this function of g of x, well, let's see what happens if I put huge positive numbers in here. I get positive over a positive. So it's going to be positive infinity. What happens when I put huge negative numbers in here? I get a negative over a positive. So that's going to be negative infinity. So when we're looking at end behavior, we're going to say what's the limit as x approaches infinity and what's the limit as x approaches negative infinity. And for these one, there is no limit. They just go to positive infinity, negative infinity. They just keep going in both directions. All right. So this one's already been factored for us, which is fantastic. So we have the function, then we have it factored, and we're going to ask for the domain. Well, what numbers can't I put in here? I can put all reals except x can't equal negative 2 or 2. And so then let's reduce it. Well, these two simplify out, and I end up with the reduced function. You see the RED there? That means reduced. So we have x plus 4 over x plus 2. Okay, so that's our reduced function. So where do we have a vertical asymptote? Well, we have a vertical asymptote at x equals negative 2. It's odd because the power of this factor is an odd number, so that means it's an odd vertical asymptote. What about our whole? Okay, well the whole that we crossed out is going to be at x equals 2. What's the other part of that whole, right? So we know the x value, we need to find the y value. And to find the y value, we put 2 back into the reduced function, if you remember that. And so we get 2 plus 4, which equals 6, over 2 plus 2, which equals 4. So we get 6/4, or 3/2. Fix that, it disconnected. All right, got it reconnected. So the whole is at 2 3/2. So that's where we're going to have the whole, because we could just plug that number back in. And then end behavior again, horizontal asymptote. What's going on with our horizontal asymptote? So we look at this original function and we see that we have x squared over x squared. It doesn't matter if we do that one or the reduced function. They're the same. So it doesn't matter when we're looking for horizontal asymptotes and end behavior. But we can look at this first one just because it's easier to think about. So we have x squared over x squared. So this is a case where we have the same degree on top and bottom, which means we're just going to take the leading coefficient of the top divided by the leading coefficient of the bottom. So our horizontal asymptote is at y equals 1, because it's 1 divided by 1. And so let's write that in limit notation. Limit as x approaches infinity of this function equals 1, and the limit as x approaches negative infinity of this function is also 1. It's because it has a horizontal asymptote that it's approaching at both sides. Now just remember, for rational functions like this, that means a fraction, there's always only going to be one horizontal asymptote, but for radical functions, you often are going to have 2 horizontal asymptotes, so make sure to check for those. All right, we'll come back with another video to do some actual curve sketching. So once you find out all of this information about a function, how do we actually sketch the curve? You have some papers in your notes that will help you, so go ahead and pull those out and we'll look at the next video.